So we're going to be looking at this idea of atom economy today. And at the beginning of the beginning of our remote teaching last term, we looked at percentage yield. Okay, so I'm just going to remember percentage yield. Now, percentage yield was all about the actual amount we produced, or the actual amount of product or a substance of interest compared with the theoretical maximum. Okay, now atom economy is different. And atom economy is all about efficiency. And the question we're really asking is how much of the reactants are ending up as useful product. And therefore, in a way, it's all about sustainable production. Companies don't want to be using lots and lots of reactant that end up as waste, okay? Especially when we need to be thinking about, in general, just wasting less, okay? And therefore making it economical. But also the process, or the effects of having lots and lots of waste is, well, what about if the waste is hazardous? And if the waste is hazardous, then how are we going to effectively dispose of it? Okay, so thereby, by making more and more products that are useful, it means that companies are going to be working more efficiently. Now, it is also worth saying at this point that there are other factors to consider when we choose which reaction pathway to use. So factors to consider. So first of all, atom economy, which we're going to look at today. The second one being percentage yield. The energy costs. So companies are always thinking about burning fossil fuels. And therefore, not surprisingly, the environmental impacts. Of this. And in addition, sort of the cost of the reactants. If you remember, we talked about before that there are different reaction pathways perhaps that are possible for a particular reaction. It might be that one of them can use cheaper reactants, and therefore that might be preferable for a particular company to use. And also whether the reaction is reversible or not. Because sometimes in a reversible reaction, if I just remind you here, perhaps if we had reactants A plus B to form C plus D, a reversible reaction is one that can both go in the forward direction and the reverse direction. And so sometimes perhaps if a lot of D was used and actually C was our product, we could put D back into the reactants to be used again. And therefore these are all considerations that people will use when they decide to choose which reaction pathway they're going to use. It is just sort of perhaps worth therefore adding that any reaction that forms other products other than that is useful, will fall short of 100% atom economy. So the higher the atom economy, or higher the percentage atom economy, the more efficient the reaction. So to calculate atom economy, we'll be using the following equation, and I will pause this video afterwards for you to have a look at my worked example coming up. Okay, well, atom economy is equal to the MR of the desired product divided by the MR of all reactants multiplied by 100. Okay, a couple of things to add here. Multiplying by 100 because it is a percentage. And remember, the MR is the relative formula mass. So in this case, we'll be using mass numbers of each element. To calculate these. It is just worth knowing that when we calculate the relative formula mass in atom economy, we do need to include the balancing numbers. And that's because we need to be having a look at the moles of reactants and products that we have. This balancing number is otherwise accounted for in reacting mass calculations where we've done the ratio step. However, with this, we do need to be including the MR, so we'll cover that in the next video. Just for your reference, you might want to pause this on the end screen here. Where's it gone? There is the specification points about atom economy that you'll need to be aware of.